Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good day to all my students. Alright, for today's class, I would like to start the new topic called as unit operation. Unit operation. What is unit operation? In chemical engineering, a unit operation is a basic step in a process, meaning that unit operation is a fundamental equipment in order to complete a process. There are many types of unit operation that involving a physical or chemical transformation, such as separation, crystallization, evaporation, filtration, polymerization, and isomerization. In order for us to determine the physical change or chemical transformation, we have to identify the phases changes, okay, such as separation. There are many types of separation. Okay, let's say to separate multi-components to single components by using fractional distillation. Okay. So we know that these multi-components that enter to the fractional distillation contains of single liquid phase. And we use the fractional distillation to separate all these multi-components to single components, okay, by using boiling point working principles. Alright, so this involves with chemical transformation because it relates to the concentration changes between multi-components to single components. Alright, however, there is a physical change of boiling point that also involve between liquid and vapor form. Alright, then we go to crystallization. For crystallization, it involves with the change of high temperature liquid to sudden cooling down to form a solid form. Alright, so we know that from liquid to form solid, it involves with physical change that we can see the crystal by our own eyes at the end of the process. And during the process is involved with the chemical transformation because it involves with the changes of the molecules inside the phase of liquid to form solid, whereas the numbers of atom and the condition of atom is start to completely pack and closer to each other. Okay, then we go to evaporation. For evaporation, it changes the liquid to form a vapor. So it involves with the physical change because we can see the level of a liquid that successfully transformed into a vapor of gas form is slightly reduced to form a vapor of or gas. Filtration. Filtration is a separation process between liquid and solid. Okay, let's say in order to separate between tea leaf and also water. Alright, so we use the filter and we passing through the hot tea water, okay, through the filter. So at the end of the process, okay, we can see only the decanted hot water will passing through the filter to the glass, and the tea leaf is remain on a filter surface or the surface of filter. So this is a physical change. We can see a different type of phases like solid on a filter and liquid in a glass. Polymerization and isomerization are the process or the unit operation processes that involve with chemical transformation because it involves with the bonding of the bonding or the chemical broken down of the bonding of the molecules. Okay, a process may require many unit operations. It is impossible for a complete chemical engineering based process involved with only one unit operation. It requires many types of unit operation. The main target is to obtain the desired product from the starting material or so-called feedstock or starting feedstock. One of the combination of several unit operations involving in the industrial-based application is the milk processing operation. You can see from this diagram the various types of unit operations involved in the steps of processing milk such as homogenization, pasteurization, chilling, and packaging. Homogenization is a process by which the fat droplets from the milk are emulsified and the cream doesn't separate. Or it can also stand as is a process of making teams uniform or well mixed. Pasteurization. The second term is pasteurization. Pasteurization is a process in which the packaged or non-packaged foods are treated with the mild heat. Mild heat is normally the temperature less than 100 degrees Celsius in order to eliminate the bacteria, pathogens, and at the same time extend the shelf life. This pasteurization is actually intended in order to destroy or deactivate some organism or enzyme that contribute to the spoilage or risk of disease. Okay, then we go to chilling. Chilling is a process by which the raw or the processed food is being cooled to a temperature in between 0 degrees Celsius to 5 degrees Celsius. And finally, packaging. Packaging is a process of designing, evaluating, and producing a package. Packaging can be described as a coordinated system of preparing the goods or the items for transportation, warehousing, logistics, sales, and etc. Alright. Normally, packaging contains protection, preservation, transportation, and selling. All these type of unit operations are connected, okay, to each other in order to create a complete overall process. Chemical engineering unit operations consists of 5 classes. The first is fluid flow processes. For the fluid flow processes, it involves with the movement of fluid, solid, and liquid from one point to another point or from one location to another location. For example, fluids transportation, filtration process, and solid fluidization. The second class is heat transfer processes. For the heat transfer processes, it involves with the movement of heat from low temperature to high temperature or vice versa. For example, evaporation process involves with the transferring of heat from low temperature to high temperature. The second process for heat transfer processes is heat exchange. The equipment or tools that use the heat exchange principle is heat exchanger. The heat exchanger will be working with based on two different principles. The first principle is heating heat exchanger. For the heating heat exchanger, it will be transferring the heat from a lower temperature to higher temperature. Then the cooling heat exchanger will use the principle of transferring the heat from higher temperature to lower temperature. Then mass transfer processes. For the third class of chemical engineering unit operation will involve the mass transferring process. For example, gas absorption, distillation, Extraction, adsorption, and drying. Gas absorption and adsorption is applying the concept of separation by solid adsorbent, whilst distillation is applying the concept of separation by phase creation. Extraction is using the principle of separation by phase addition, and drying is also has the similarity to the distillation. So we can say that the mass transfer processes is most likely um, as the movement of molecules from one phase to another phase. Thermodynamic processes is categorized as the fourth class of chemical engineering unit operation. For example, gas liquefaction and refrigeration. For refrigeration, a refrigeration system involved with four components such as a compressor, evaporator, condenser, and throttling valve. The combination of these four components will complete the refrigeration system. The mechanical processes involved with the function or the working principles of the mechanism. When we talk about the mechanical process, we have in mind a system in which one or more unchanging objects can move relative to some reference frame. And the movement of these objects are described completely by the Newton's law of motion. And the objects are categorized by their masses, locations, velocity, and also accelerations. However, they may be subject to their effects such as the force field, whilst the magnitudes can vary with locations and time. We stipulate that the volume, pressure, temperature, entropy, composition, and internal energy of the individual object will remain the same or being kept constantly throughout the process. For example, solid transportation. There is no changing of the solid by transporting from one point to another point. Crushing and pulverization. Crushing is the process that reduces the particle size from the larger size to the smaller size. Screening and sieving also involve with the mechanical process. There is no change of the masses, okay, the location or the velocity as well as the acceleration. However, the screening and sieving are involved with the separation of different particle sizes. Okay, the chemical engineering unit operation also falls in the following categories, which involve the element from more than one class. Okay, the combination is called a mixing. Separation is a category that involve the elements of distillation and crystallization. Reaction it always involve the chemical reaction. Okay, let's say to form ammonia, we mix between nitrogen gas and hydrogen gas. In the chemical processing industries, many similarities exist in the manner in which the entering feed materials are being modified or processed into final materials or chemical products. There are a series of unit operations involved, such as reaction, separation, and heat recovery. The reaction is a process in which the components is react to another components to form a new component. Separation is a process of separating a mixture to be a separated channel or separated stream. Heat recovery is a process in which the heating or cooling are processes involved. The entering feed materials are break down into a series of separate and distinct steps, so-called unit operations. However, the unit operation nowadays being superseded by the modern term called as separation processes. The separation processes are common to all types of chemical process industry. We can say that the separation process is a major or main process involved in the chemical-based engineering process industries. There are 5 major of unit operations involved in chemical-based engineering industries such as mixer, splitter, reactor, separator, and heat exchanger. Okay, we will discuss one component to another component one by one. The first unit operation is a mixer. In industrial process engineering, mixing using mixer is a unit operation that involves manipulation of heterogeneous physical system in order to make it more homogeneous or well mixing. Mixing is performed in order to allow the heat or the mass transfer of the molecules of this component or substance to occur between one or more streams, component, or phases. There are 2 or more entering streams and only one exit stream for the mixer. And the stream can be at any phases such as solid, liquid, or gas. Okay, the material balance that involved at the mixer are represented as the component of A plus component of B to form C. Alright, so this is the schematic diagram of the material balance. Okay, let's say the feed of A at the mass flow rate of kilogram per second will mix together with feed B at the same unit of mass flow rate to form new product, which is C. Alright, so we can say here C is a product of the mixture between A and B. Alright, for example, the continuous stir tank reactor. Right, so you can see here the motor. The motor is used to supply the electric current to the stirrer or agitator to start mixing and make it homogeneously and well mixed. Okay, at the same time, the cooling jacket is being installed on the wall to maintain the temperature inside the mixture. So it is important for us to make sure that this condition of mixture is stand within the desired condition of temperature, pressure, and phase. The second unit operation is called as a splitter. Okay, for splitter, all the composition are equal because there is only one independent material balance. Okay, for example, okay, the material balance of feed A is entering to the splitter, and after some time, the leaving stream will have the same composition, which are product B and product C. Alright, so you can see the example of airflow splitter here. Right, so feed A is coming from this stream, and after some times the airflow will come or will leaving the splitter here that have all the same compositions. The third unit operation is called as a reactor. In chemical engineering, a chemical reactor is the main backbone for the process. The chemical reactors are the vessel that designed for the chemical reactions to occur. It can also be referred to reaction vessel. In a reaction vessel, the reactants contains other substances or raw material, or it can also call as a feedstock that chemically reacted in order to form the products. The products is not limited to the desired product. There are 3 types of products such as main product or desired product, undesired product, and also unreacted product. The design of a chemical reactor deals with multiple aspects of chemical engineering. As a chemical engineer, you need to design the reactor in order to firstly maximize the net present value for the given reaction. Secondly, to ensure that the reaction proceeds with the highest efficiency towards the desired output product. As I mentioned previously, there are three types of product: desired product, undesired product, and unreacted product. So as a chemical engineer, you need to design the reaction vessel that consists or that can produce the high amount of the desired output or product as compared to undesired or unreacted product. Finally, as a chemical engineer, you need to also consider to produce the highest yield of product while requiring the least amount of money to purchase and operate. So the highest yield of product is come first, followed by the other components such as involving of energy, high energy, or the allocation of money needed for purchasing the equipment or to maintain the operations. There are two types of reactions occur in a reaction vessel. The first type is called as endothermic. For endothermic process, the process that absorb heat. Okay. Then the second type of reaction is called the exothermic reaction or process that release heat. For example, there are many types of reactor in chemical engineering based industries such as pressure reactor, batch reactor, continuous reactor, semi-batch reactor, and catalytic reactor. For the material balance, the general materials balance of reactor consists of the reactants produce product. The schematic diagram of reactor is shown here. There are two types of feed A and feed B. Basically, feed A is called as limiting reactant, the reactant that is being limited for the process, and the feed B is called as an excess reactant. Excess reactant to make sure that all the limiting reactant is being successfully reacted. And this component A and component B will be chemically reacted in order to form three types of product. The first product is called as product C, which is desired product. Product D is called as undesired product. For both desired product and undesired product are two components that newly formed from the reaction between A and B. However, there is a product E called as unreacted product, which is the product the reactant that has not successfully been reacted throughout the process. So based on these three types of product, it can be shown by using this total material balance. Feed A plus feed B is equal to product C, D, and E. So one example of the reactor or the chemical reactor is called as a stir tank chemical reactor with a cooling jacket. Okay, so the stir tank chemical reactor is one of the example of continuous process chemical reactor. Okay, so the function of chemical reactor is to form a new product from the combination or from the reaction between two substances. The function of cooling jacket is to make sure that the condition in the tank is being optimized throughout the chemical reaction process. Based on the schematic diagram of the reactor, you may find or discuss with your partner what is the example of reaction in chemical industrial application that can be categorized for the types of reactant in the products. Okay, for example, I give you the complete combustion process. Okay, as we know, the complete combustion process involves with the combustion of coal and oxygen to form CO2, H2O, and also energy. Okay, so the coal, in order to make sure that all coal is being utilized or being successfully combusted, we need to supply the excess amount of oxygen. Okay, and after sometimes the product will come out slowly and continuously and form three types of product. The first one is called as CO2. CO2 is called as a main product rather than desired product, because desired product always related to the required product that can increase the efficiency or maximize the purity of the product. But for CO2, it is not suitable to name it as desired product. So that's why it is categorized as a main product from the combustion process. The second is H2O in the form of vapor. It is the undesired product. Then the product A will be the excess of oxygen that has not been reacted, okay, to the coal, and it is just flowing, okay, throughout the process and come along to the living stream. Now we move to general separation technique. The separation processes deal mainly with the transfer and change of energy and materials by physical and the combination of physical and chemical, so-called physicochemical. The important purpose of separation processes can be combined in various sequences in a process. There are 5 types of separation techniques. The first type of separation is separation by phase creation. It creates a second phase that is immiscible to the feed phase, and normally the first phase is miscible to the feed phase. For example of this separation by phase creation are distillation process and crystallization process. The second separation technique is separation by phase addition. For this separation by phase addition, it introduces the mass separating agent in the form of solvent. For example, solvent extraction process. The mass separating agent may be partially immiscible with one or more species in the entering feed stream that coming to the separator, or may be completely miscible with a liquid mixture. However, this MSA or mass separating agent brings several disadvantages, such as need for an additional separator to recover the MSA for recycling, possible contamination of the product in the MSA, and more difficult design procedure. Then the third separation technique is separation by barrier. Normally, the separation by barrier, we use a membrane separation process. The function of membrane that installed in the middle of separator is to restrict and or enhance the movement of certain chemical species. The fourth separation process is called as the separation by solid agent. The separation by solid agent requires the addition of solid particles that act directly or as inert carriers for separation process. For example, adsorption process, chromatography process, and ion exchange process. For the adsorption process, the application of solid adsorbent, for example, molecular sieve, activated carbon, silica gel, and PET column are being applied. The second example of separation by solid agent is chromatography. For the chromatography process, the application of solid adsorbent or liquid adsorbent on solid support is being applied. The third examples of separation by solid agent is ion exchange process that requires the application of resin with ion active site. Then we move to the last separation technique is called as the separation by force field or gradient. For the separation by external field or force field or gradient, it applies the external fields of various types. For example of the separation by force field or gradient centrifugation, thermal diffusion, electrolysis, electrodialysis, electrophoresis, and field flow fractionation. I will discuss further by taking three examples. The first examples of this type of separation by force field or gradient is centrifugation. For the centrifugation, it applies the external energy, so-called centrifugal force field, to separate according to the molecular weight of the component. For example, separation of uranium isotope and separation of plasma from blood. The second example, so-called electrolysis. For the electrolysis, it uses the electrical force field in order to accumulate the anions and cations to the specific poles, so-called cathode and anode. The third example is called as the field flow fractionation. The field flow fractionation use the application of the laminar flow in the force field. For example, an electrical or magnetic field or thermal gradient is established perpendicular to the laminar field, and you can further learn in this field flow fractionation in the separation process. Then we move to the separation processes and separating agent by phase creation or addition. Okay, the example of the phase creation or addition, you may see on the slides, there are several processes with respect to the separating agent and application are being shown. The first one is absorption process. For the absorption process, it uses solvent as mass separating agent or MSA. So this is categorized under the phase addition. For example, removal of CO2 and H2S from natural gas with amine solution. The second process is called distillation process. For the distillation process, it uses heat. Okay, so for heating process as separating agent, this is the example of phase creation. The application of the distillation process is propylene and propane separation, production of gasoline from crude oil, and air separation. Then the third process, so-called evaporation. Evaporation uses heat as separating agent. This is also categorized under phase creation. Okay, example, water desalination and manufacture of sugar. The stripping process. For the stripping process, it uses the stripping gas. For example, removal of benzene from wastewater. For the stripping process, it is categorized under phase addition. Then extraction. Extraction use solvent as separating agent or MSA. So this is categorized under phase addition. For example, recovery of benzene, toluene, xylene from gasoline reformate, and removal of caffeine from coffee. Then drying process. Drying process is applied heat as mass separating agent, and this is the phase creation example. For example, drying of ceramic, plastics, and foods. In chemical separation processes, a mass separating agent, or be shortened as MSA, is a chemical species that is added to ensure that the intended separation process takes place. It is analogous to an energy separating agent, which aids separation process via additional of energy. Now we move to separation processes and separating agent based on a barrier. There are many types of the separating processes based on a barrier. For example, reverse osmosis use non-porous membrane with pressure gradient as a mass separating agent. For example, desalination of seawater. Second process is dialysis. Dialysis is use the mass separating agent of porous membrane with pressure gradient in order to recover the caustic from hemicellulose. Then microfiltration and ultrafiltration are applying microporous membrane with pressure gradient as a mass separating agent, okay, to separate bacteria from drinking water for microfiltration and to separate with from cheese for the ultrafiltration. Then pervaporation is use non-porous membrane with pressure gradient as a reverse osmosis principle in order to separate of azeotropic mixtures. And finally, liquid membrane is used liquid membrane with pressure gradient in order to remove the hydrogen sulfide from the mixture of gas. Then we go to the examples of MSA and application based on solid agent. There are three processes involved for the separation process based on a solid agent that I have been explaining before. There are adsorption. Adsorption use solid adsorbent or resin. For example, separation of meta-paraxylene, air separation, gas separation, and water demineralization. Second process of separation process based on a solid agent, so-called chromatography. Chromatography is use the solid adsorbent or liquid adsorbent on a solid support. For example, separation of xylene isomers and ethyl benzene. And the third examples of separation process based on a solid agent is called as ion exchange. For the ion exchange, it uses the resin with ion active site as mass separating agent. For example, demineralization of water. Right, now we comes to the last examples of separation process by applied force field or gradient. There are 5 examples of processes used to explains about the separation processes by applied force field or gradient. For example, centrifugation process that use the centrifugation force field. For example, separation of uranium isotope. This separation is using the principle of a different molecular weight. Then thermal diffusion. Thermal diffusion is applied based on the thermal gradient principles. For example, separation of chlorine isotope. This application also applying the difference of molecular weight. Then electrolysis process. The electrolysis process use the electrical force field as a mass separating agent, okay, to separate the charge, different charge, such as anion and cation to the different poles, such as anode and cathode. For example, the concentration of heavy water. For the concentration of heavy water, it use the heavy metals like ions, ferrum, okay, in the mixture of water. So different ions will have the attraction or affinity towards a different charge or poles, so-called anodes and cathodes. Then electrodialysis. Electrodialysis is using the electrical force field and membrane as an external force field. For example, the desalination of seawater. And finally, the examples of separation process by applied force field or gradient is electrophoresis. Electrophoresis also applying the principles of electrical force field. For example, the recovery of hemicellulose.